Okay, to find the final amount in a word problem on compound interest, these word problems look like this. Dan deposited $4,000 into an account with 4.1% interest compounded annually. Assuming no withdrawals are made, how much will he have in the account after 5 years? So for these, we are going to use a formula. So I'm going to write down that formula for you first. Formula is A, which is the amount after T years, is P, which is the principal or initial amount, times 1 plus R, which is your interest rate, divided by N, which is the number of times it's compounded annually, raised to the N times T. So A is the amount after T years. P is the principal, which is your initial amount. So if T is 0, this whole thing becomes 1. So your initial amount is the time after 0 years, right? And then R is your rate, which needs to be a decimal. And N is the number of compounds per year. So basically, the number of times that interest is compounded annually, and T is your time in years. Okay, and then as far as your N, when N is 1, that would be annual. So the interest is compounded annually. When N is 2, that's semi-annual. When N is 4, that is called quarterly. And when N is 12, that's called monthly. All right, so now we have all of this. So let's move this up a little bit. Here. Okay, and I'm just going to write down the formula again. So A equals P times 1 plus R over N raised to the N T, right? So in this case, so A is always going to be what we're trying to find. So Dan deposited $4,000 into an account. So the amount he deposited is his principal or his initial amount. And the interest rate is 4.1%. So that's my rate. R is 4.1% or 0.041. And it is compounded annually. So compounded annually means N is 1. And it wants to know how much will we have after 7 years. So my time in years is 7. So I'm just going to put all these values into that formula. A equals 4,000, 1 plus R over N, oops, numbers in, 1 plus R, which is 0.041, divided by N, which is 1, raised to the 1 times 7. So now we just use the Alex calculator, put that all in. Oh, so also when you're converting the rate, remember 4.1% rewritten as a decimal, I divide that by 100%. And that's where I got the 0.041. So now I'm going to put this formula in. I leave out this part, the A equals. So it's 4,000, parentheses, 1 plus 0.041 divided by 1. Move your cursor out to add the end parentheses. And then we use this to raise it to a power, 1 times 7. Okay, and when we have it all done, we just hit equals. And then it wants it to the nearest cent, so that's 2 decimal places. That number to the right is an 8, so that means I'm going to raise that 5 to a 6. So it is $5,299.26. All right, let's do one more. Line. All right, so this time, suppose $2,000 is loaned at a rate of 16.5% compounded monthly. Assume that no payments are made. How much is owed after 3 years? You can use the same formula. Right. So $2,000 is loaned. That's my P. At a rate of 16.5%, that's my R, 16.5%. We're going to divide that by 100% to get 0.165. And it is compounded monthly. That means that N is 12. And it wants to know the amount after T equals 3 years. So again, we'll put that into our formula. 2,000, 1 plus 0.165 divided by 12, all raised to the 12 times 3. So we want to grab our calculator. I'm just going to put this formula in. 2,000 parentheses 1 plus 0.165 divided by 12. Move your cursor out here. That's raised to the 12 times 3. Once we have it in, you should look at it, make sure it matches, and then just hit equals. And again, it wants it to the nearest cent, so that's going to be 3269.95.